Okay, so I guess my encouragement, all right, for those of you watching the video, I want to encourage you to come to class on Friday, and then I guess I'll have some designated time on Friday to form groups, or at least start thinking about groups, start doing stuff. So yeah, today we'll cover this thing, Chapter 5, working with multiple tables. And then on Friday of this week, I will formally introduce and talk about the final project, okay? And the final project, is a big portion of your grade. And I really think, in my personal opinion, is going to be where a lot of the actual learning happens. We for the homework. I mean, so when you learn stuff in a class, there's different parts, right? Part of it is like you sit and watch these lectures, and I try to present material. Part of it happens when you read the textbook, and you kind of read through that content there. And then learning happens when you do your homework, and we have data camp homework, we have homework from the textbook, and I think that helps. But my opinion or my belief is that for this class, a lot of learning will happen when you do this project. And so at a certain point, I'm no longer going to, for the first few weeks of class, I assign homework, every week from data camp, and, you've got these different homeworks. But at a certain point, I'll stop assigning kind of homework, and basically I want all of your energies regarding this class to go into that project, okay? A big aspect of the project will be, finding an interesting data set that you want to work with. And so anyway, on Friday, I will talk more about what this project looks like, what kind of things I expect from the project. And we'll, in class, we'll have some time to establish groups. Maybe I should make just a tiny bit. I will include here. I'll make an announcement. Your group can get some extra credit if you form a group on Friday. I will give your group some extra credit. So if you're watching the video, all right, come to class on Friday, and your group can get some extra credit. Okay, and then if you don't come on Friday, then you got to figure out your group online, which is way harder. And then if I will have a final deadline of 4th week Friday to have kind of groups established, or maybe I'll say 4th week Thursday. And so 4th week Friday rolls around and you're not in a group. I will just look at who hasn't formed a group, and I'm just going to randomly group students together, okay, or arbitrarily. I don't like to use the word randomly, because random means truly. I'm just going to arbitrarily do it, okay, and it's kind of like roommate selection, and sometimes it doesn't work out so great if you have no say in the matter, right? So, sometimes it doesn't work out great even if you do have say in the matter, right? You pick some groups, and then it turns out somebody that you picked to work with turns out to be a total flake, and that is always a risk in any kind of group project. I think UCLA students are very familiar with this, probably because when you were in high school, you were always designated the group leader, right? and you felt like you had to carry the weight of your entire group on your back, type of thing. But anyway, so I will say, and I'll send out an announcement just to make sure. So if you come on Friday and you form your group on Friday, I will give you a point of extra credit for your. I'll give you some extra credit for your final group project. But other than that, that's what we'll have there. Okay, so we'll talk about that, and then we'll cover more about what the group project looks like. But today we will talk about working with multiple tables. So again, the first few weeks, and I know it feels like, oh, there's so much coding and all of that, and apparently that was not expected. A lot of students were not expecting the amount of kind of code here, and I apologize that it's a bit of a surprise. But yeah, the truth is in any kind of modern application, of data science is you're generally working with fairly big data sets, and analysis using, say, just Excel or Google Sheets just isn't going to cut it. And so how do you interact with data sets that are bigger, or data sets that can't fully be done with Excel? I mean, you know, to give credit to Excel and Google Sheets, you can do quite a bit with those things. And, you know, we could probably have like a side thing, not in this class, but like, you know, some kind of side topic where it's like, oh yeah, you know, what can you do with Excel and what can you do with Google Sheets? Quite a bit, but there are limits to it, and so certainly the way we interact with it, you know, any kind of interesting data set most of the time is via coding, okay, and we have options regarding how to interact with it. Python being a choice. In our class, we've chosen R and RStudio. I think good choices as well. And so we talked about being able to just visualize that data, creating little charts, little graphs, you know, point geometry, columns for bars, lines, and that's pretty good. And then also learning how to create summary values. How do you calculate the mean or the median, or, you know, standard deviation, or any of these kind of summary things. Sometimes we have data, and the data is spread across multiple tables, okay? And so, so here we have these two table verbs, and these are commands or functions that allow us to kind of join two tables together. And you can then expand this to like 3 tables or 4 tables. You just join them 2 tables at a time. So if you want to join 3 tables, you know, you join tables A and B together, right? And then once you have that joint table, then you can join it with table C, right? And you sometimes you have to kind of think about these things, and sometimes it makes sense to join A and C together and then join table B. Sometimes it makes sense to join B and C together first and then join it with table A. Sometimes it really doesn't matter, but you know, you can kind of do this. You know, if you have a whole bunch of tables, you can kind of keep joining them together, you know, 2 at a time to form what you need. Okay. The type of join that so bringing 2 tables together is known as a join, and we are going to look at what's called mutating joins. Okay. There's other operations, the filtering join and the set operations and stuff. But we will focus on mutating joins. Some of you have experience with SQL. Some of you have heard of that. Some of you have no idea what that is, okay? I'll just say there's a lot of similarity between what we're covering in today's lecture and SQL. And so this might look familiar to some of you. Some of you have never heard of SQL or have never used SQL, and it doesn't matter, okay? We're just gonna look at this, okay? And then some of you will be like, oh yeah, I've heard of SQL, and every time I look for a job posting, it says you need to have SQL experience, but I don't actually have any SQL experience. So basically, if you learn how these mutating joins here work, that will set you up pretty well for like how you would use SQL. I mean, SQL's a lot of the same kind of ideas, just maybe the command is a little bit different. The command structure is a little bit different, but anyway, it's basically like a lot of these things are like, how does a Venn diagram work, right? Okay, so we're gonna have this very, very, very simple example. I've got 2 very small tables with very simple values in here, okay? So I have a people table and I have a states table, okay? And I guess they're called tibbles when we use the tidyverse. So in the people table, we have a name column, okay? And the names, I've got Adam, Betty, Carl, and Doug, A, B, C, D. And then we have states, CA, CA, NY, and TX, okay? And then I have a states table that we'll kind of go from an abbreviation to the state name, and our abbreviations are CA, NY, and WA, and our state names are California, New York, and Washington. So CA goes with California, NY goes to New York, WA goes to Washington. So if I just kind of print these out, this is my people table. Again, 4 rows, Adam, Betty, Carl, Doug. Adam comes from state CA, Betty comes from CA, Carl comes from NY, Doug comes from TX. The states table, we have CA, the abbreviation CA corresponds with the state name California, abbreviation NY corresponds with the state name New York, and the abbreviation WA corresponds with Washington. And so our first join is we can do something called the left join, okay? And here I'm going to take the people table and I'm piping it into the function left join, okay? So what this means is the people is the left table and I'm left joining it with the states table. The states is the right table, okay? So we got the people is kind of the first table and it's going into the join function. So this is my left table and this is my right table. People is the left. And the left join says we are going to keep all of the rows in the people table, okay? Keep all of the rows in the left table. And if we can find a match in the right table, we will add the columns that match in the right table, okay? And if you don't find a match in the right table, then return an NA, return a missing value, okay? How am I joining the left table with the right table? We are going to match by looking at this column state, which has values like CA, NY, and TX, and we're going to look for matches by looking for matches in the column abbreviation. So I'm saying take people, join it, okay, with states. How? I'm going to match by using the state column and matching it with the abbreviation column. Okay, so I'm doing state equals, and state in quotes equals to abbreviation in quotes. Right? And so what we see is, again, we've kept everything in the people table because that's our left table. I've got Adam, Betty, Carl, and Doug. Adam, CA, we have a match with we have a match over here. And then, so what are the additional columns in the states table that don't exist in the people table? We add this column state name. Betty, CA, that corresponds to California. Carl from NY, that corresponds to New York. Doug, TX, in our states table, TX is not a value that shows up in the abbreviation, so it says, I don't know what this is, okay? Now we know it, I mean, we know this is Texas, but and for whatever reason, it wasn't included in our states table. So this, obviously, if you're going to join something, you want to try to have as much complete data as possible. But sometimes you end up in a situation where it's like, oh, here's a year, we're in the year 2023, and maybe you only have data up through 2022 or something like that. Okay, and so you might not have a match. Okay, for something like states, obviously you want to make sure all 50 states are all possible values. So you include things like DC and Puerto Rico and Guam and the Virgin Islands and stuff like that into all of those kinds of states or territories or things like that. You want to have it as complete as possible. Okay, so that's what the left join looks like. Okay, the right join is very similar, except we are going to keep everything in the right table. And so again, we are taking the people. People is going into the join function and states. So people is still my left table. And I'm doing people right joining with states. So states is people still the left table and states is the right table. And so what does this look like? We are keeping everything in the states table, okay, which is the right table. We're still matching state on abbreviation. And if we don't have a match in the right table, we have an NA. And so what do we have? We end up with California matches with Adam over here, okay? And then we have CA California matches with Betty over here. We have NY New York matches with Carl, okay? And then in the right table, we have a WA Washington. We have no one in the people table that matches that, so we get an NA there. Okay. What happened to Doug and TX? Okay. Well, we don't. In this case, it doesn't matter. We don't even include that because we're only making sure that everything in the states table, the right side table, has a match. Okay. So if you look back to the previous page on the left join, okay, we could say, oh, what happened to WN Washington? Well, it doesn't appear. It doesn't appear anywhere in this thing. Okay. So we're just saying, okay, well, I don't. We're only looking at the left table and looking, adding values if there's a match in the states table. And over here, it's just kind of the opposite. We're only looking at the right table and we're adding values or matches if there's something in the left table, in the people table. Okay. And so if there are multiple matches for something like CA California, all of those get included. Okay. So there's multiple matches for CA. So we're going to add Adam, another match for CA, and we're going to add Betty. So we're keeping everything in the right, adding all of the matches on the left. Does that kind of make sense? Now, here, let me, I want to show you, I could get the same results with left join if I just kind of swap the order of these things. So if I did left join states people, I would get something very similar to right join people states, if that makes sense, right? Because the order in which I specify these things indicate the order in which the tables occur. You have a question?
Yeah. So
yeah.
In your call, like C, I guess for the variables, it doesn't matter what order you put them in, right? Because it's just only left and right table determines. Like state equals abbreviation, you could do abbreviation equals state, it wouldn't matter.
Well, abbreviation equals state, so it's going to be state corresponds to the left table, so it's going to be state from people matches with abbreviation from the states table.
So like a syntax thing, you just want to match them.
They have to go. They go in respective order.
Okay.
Okay. So yeah, but let me show you. We get similar results. So let me run this. Let me create this table. Okay. So here I have. So we're going to do people left join states by equals C, state equals abbreviation. All right, so this is what I have, and when I did people right join, this is what I get here. Okay, so people left join, we get Adam, Betty, Carl, Doug. We get an NA for the state name. Okay, when I do the right join, we keep all of the states, California or CA, NYWA. And we get, matches with Adam, Betty, Carl, and then an NA here. We're gonna get similar things. So if I do, states, right join, people, and then so again, if I do states, right join, people, I have to change the order. I gotta do abbreviation from states equals state in people. Okay, what am I gonna get here? States, right join, people. Will I get Doug or will I get Washington in the resulting table? If I do states, right join, people. Yeah, if I do states, right join, people, we're gonna prioritize the right table. In this case, the right table is people, so we're gonna keep Doug, and we're not gonna get Washington, okay? But notice how it gets matched, okay? Because I specified the states table first, right? And so our states table has the state information, okay? So it's going to keep, because I specified the left table here is states, the right table is people. We're gonna keep everything in the states table, CA-NY, okay? And then the right table being people gets added over here. So this, okay, states right join people produces very similar results as people left join states, but there is a difference, okay? So let me just kind of compare that. So we have states right join people is very similar to people left join states. What are the differences? Okay, the difference is the column order. Okay, we start off with the state columns, the columns from the states table, and then we add on the column from the people table. Okay, and because the states table has a different column name that for the CA, you know, the things with the kind of postal abbreviations. Okay, we end up with the column name from the states table. Versus when I do people left join states, we end up with name, state, state, name. When I do states right join people, we get abbreviation, state, name, name. Okay, so similar results but different, right? Okay, and then so let me again. What if I do? So let me do. We have people right join states. Okay, so this is what we have here. So if I do something similar and I do, so in this case, I'm going to do states left join with people. And in order to do this, I have to change this to abbreviation equals states. Okay. What is the resulting table going to look like here? I have to fix my typo here. Okay. So up here I have people right join states. And if I do this, states left join people, first of all, am I going to have Doug or am I going to have Washington? We'll have Washington, okay? And what will my column names be? It'll go abbreviation, state name, and then the name of the person, okay? So here we have Washington, we don't have Doug, okay? And then again, we're starting off with the columns from the states table, abbreviation and state name, and then that's being joined with the additional column from the people table. So
it sticks it off on the right side, essentially. Right?
Yeah, so you start off with your left side table. So the structure of all of these commands is you start off with a table. Okay, this is your left table. You join it with a right table. Okay, how are you going to join it? You're going to prioritize either the rows on the left table, or you prioritize the rows on the right table, or whatever you want. Okay, and then so any additional columns, right? You're going to say match by using these things, so it's not going to duplicate that thing. But then you any additional columns, you just kind of text them on to the right side. Okay, so that's the right join. Okay, inner join is kind of like the intersection in a Venn diagram, and this is only going to give you rows where it finds matches. So here we have no Doug, we have no Washington. Okay, so here we only we have rows matches between California, CA-NY. And so we get Adam, Betty, and Carl, no Doug. We have no match for Washington, WA. So this is the inner join, okay? So you'll have no NAs if you do an inner join type of thing. And then the full join is kind of like your union in a Venn diagram. And so this is going to say, okay, let's look at your left table. Let's try to keep all the rows in your left table. Let's keep all of the rows in the right table. And if we don't find matches, we just put in NAs. So, so here I have Adam, CA California, Betty, CA California, Carl, NY, New York, Doug, TX, no match, NA, no match, NA, WA, Washington. Okay. I didn't put. Okay, I do have this in here. Okay, so that's what we have for the full join. All right, let me give you, I'll go ahead and give you your first 2 view quiz answers, or did I already give you any view quiz answers? Not yet, okay. First 2 view quiz answers are the letters C and D. Carl and Doug, okay? Your first 2 view quiz answers, C and D. Okay, there are different ways to match the tables. Probably the most common is to just name the columns that you want to match up, okay? So by is equal to, you give, the column name in the left table and the column name on the right table, and so you're gonna join them up that way, okay? If you don't specify a by, okay, dplyr or the tidyverse, so this is, within the tidyverse, you have the package dplyr, which has a lot of these kind of things. dplyr is going to just look at both tables and say, oh, these tables have the same names, and we're going to try to just match them up, right? So if you have, one table and it's got columns, I don't know, state and year, and you got another table and it's got other columns, and it's going to say, oh, you know what, we find state and year to be common or something. It's going to just match it up, right? So, so you can leave the by argument blank, and you'll let dplyr kind of try to handle this on its own. I recommend always specifying the by option, okay, just to kind of make sure you explicitly what you're going to do, okay? If the columns have, if the tables have the same thing, right, like the left table has the name column state, the right table has the column state, you can also just do by equals state, and it will look for state in the left column, state in the right, or state in the left table, state in the right table, and try to match that, okay? And then again, if you have, if the tables have different column names, like in our case, we had state in the left table, abbreviation on the right table, you have to do, column X is equal to column Y using that. Okay, what happens if we have something that's not a unique thing, right? So what if I have this, so I have the people, I have the same people, Adam, Betty, Carl, Doug, A, B, C, D. We have CA, CA, NY, TX for, I guess, their state or their location, okay? Now I have a places table, okay? And this would be unfortunate, but it could happen. Okay, I have CA California, NY New York, WA Washington, and then I have CA Canada. Okay, now it's ambiguous. So when we say Adam CA, is Adam from California or is Adam from Canada? Okay, just pretend this says location rather than state or something. Okay, and then also when it says Betty CA, is Betty from California or is Betty from Canada? Okay, now it's a little bit ambiguous, right? So what is the join going to do? Okay, it's going to join all possible combinations, right? And so sometimes if you have non-unique matches, suddenly the resulting join, you'll have like, you have 4 values in this table and 4 values in this table or something like that. But after you join them, you end up like with way more values. Okay, and so this is okay. We end up getting 6 rows, and it got cut off here. We get a warning message, but I guess the thing I want you to pay attention to is you get 6 rows in the resulting table, and you can kind of see the beginning. We have Adam CA California, Adam CA Canada. Okay, and that's going to happen here. Let me go to my the code. So these, I don't know if you've noticed, but the slide decks I produce, these are not PowerPoints. They are done in RStudio. Okay, so I have my people table. Right, here's my people table, my places table. Okay. And I've got 4 rows in people, 4 rows in places, but because I've got this duplication of CA, when I do people left join places, Okay, we end up getting 6 rows. So we have Adam, CA, California, Adam, CA, Canada, Betty, CA, California, Betty, CA, Canada, Carl, NY, New York. And again, because we did the left join, we're going to keep Doug, TX, we don't have, even though we don't have a match in the other thing. Okay. All right, if I do the right join, what will I get on the right join? Okay, so the right join, we get very similar results. Okay, Adam, CA, California, Adam, CA, Canada, Betty, CA, California, Betty, CA, Canada, Carl, NY, New York, and then we keep the Washington from the right join, and we get an NA for the no person there. Okay, so that's right join. So you have to be kind of careful. So here we just have kind of 2 duplicates, so we get kind of additional rows, a total of kind of 4 crosses between Adam, Betty, California, and Canada. But you could imagine just kind of like some larger data set. Okay, so this often mismatch, duplication kind of explosion happens when you have like something where you have like a bunch of duplicates, something like year. Okay, so if you have like people and their birth year, you're gonna have a whole bunch of people where their birth year is like 2002. Okay, and you might have like 100 people where birth year is 2002, and then maybe you meant to match like people by their name and birth date and stuff like that, but for whatever reason you didn't, and so you have this other thing where you have like the year, and you maybe have like 20 rows where you have year 2002 and a whole bunch of things, and then when you join them, it's going to suddenly do like 100 times 20, and now you got 2,000 of these combinations. It's got person number 1 matched with row 1, row 2, row 3, row 4 up through row 20, and then person number 2 matched with 1, 2, 3, 4 all the way up to row 20 or something. And so you get this explosion, and so you got to be careful. You kind of want to make sure when you identify there's some kind of matching there. Okay, dplyr thankfully gives us a warning and says like, are you sure? Because when this happens, suddenly the number of rows up, and it says detected an unexpected many to many. Okay, if a many to many relationship is expected, set relationship equal to many, meaning I was expecting multiple things with CA, and I'm expecting multiple things with CA over here. And so I want to see this kind of cross-matched duplication, but generally we don't want many to many things. Generally are not the desirable thing. Sometimes they are, but dplyr kind of gives you this warning. It says, are you sure this is what you want to do? Yeah, question.
So for our purposes, we just want to make sure there's no ambiguity in the column.
Yeah, generally when you're joining things, it's kind of like, okay, here's it's kind of like in one table you may have like customer information, okay, and within the customer information we have something like your phone number and your shipping address and your like credit card information or something like that, right? And then maybe another table has like orders, okay? And so you can have, a customer might place multiple orders or something like that. And so, you might want to have like in the full order information, you want to have like the order and the customer information all in one kind of thing. And so you might want to join those things together, right? Now, if you don't have a column called like customer ID or something that uniquely identifies the customers, and you just say like, let's just match based on name, right? So you could have an order, you can have customers with the same name, right? You could have like John Smith, okay? And you can have another John Smith, right? John Smith from Los Angeles, John Smith from, I don't know, New York, right? And then if you just say, hey, let's match, order 1, 2, 3 was placed by John Smith, and I want to match John Smith's customer information. If you just say match, customer with customer name, it's going to say, okay, order 1, 2, 3 was placed by John Smith in Los Angeles. Order 123 was placed by John Smith in New York. Order 123 was placed by, maybe there's a third John Smith from, Dallas or something like that. And now it looks like you've got 3 of these things, and it's like, oh, I don't know if that's what we wanted, right? So you kind of want to have like this unique thing where it says order 123 was placed by customer number, 655, right? And 655 corresponds to John Smith in New York, okay? Order, 124 was placed by customer 657, okay? 657 is John Smith in Los Angeles or something like that. So you want to kind of have this uniquely identifying thing. Oftentimes, you go to the doctor's office, they probably ask you like, what's your name and what's your birth date, hoping that that's like going to be unique enough where you're not going to have like, to kind of make sure they've got the right person and they're going to give like the right kind of medication or right kind of thing, right? So there's kind of this verification to kind of make sure you are unique. Okay. So yeah, we get these warnings about unexpected many-to-many relationships there. Okay, here is just a slightly more involved example. Okay, there is a library called NYC Flights 13. So in the year 2013, I guess this is like a decade old now. They just kind of looked at all of the flights either coming into New York airports or departing New York airports. Okay, so for the New York airports, there are 3 airports. There's JFK, LaGuardia, and the one in New Jersey, Newark. Okay, and so they looked at those 3 airports. There's all kinds of flights coming in and flights departing, and this is so 2013 January 1, or was it all? Maybe it was all departing flights. I don't remember. Okay, but scheduled departure time. Was there a delay? Okay, departure time was 5:17. It was scheduled to depart at 5:15 in the morning, so that's a 2-minute delay. Okay, and then the arrival time was 8:30. It was scheduled to arrive at 8:19, so that's an 11-minute delay. Its carrier was UA, which is United Airlines. Okay, and then you've got these other carriers: AA, American Airlines, DL is Delta. And then you have these other kind of things. B6, what's that? What's EV and stuff like that. So who are these things? Okay, well, and you can see it's for the entire year 2013. So there are lots of flights. 336,776 flights are kind of in our thing. So this is, pretty big data set. Again, this is one of these examples where you can't handle this in, say, Excel. Okay, it's just too big for this. So how do we interact with this? We got to write some code. Okay, these are the airlines in existence in 2013. So airlines are like one of these funny businesses where like new ones pop up and some disappear. Like some of these have been around, right? United Airlines and Southwest Airlines and Delta. Those have been around, but then. I don't know Virgin America, I think, is no longer, I think US Airways merged with, or is US Airways still? I don't know. Okay, I don't fly very often, but a lot of these kind of like ExpressJet, I don't think that exists anymore. ExpressJet was, okay, so there we go, no longer, right? Wikipedia. Very quick to change. Okay, well, I guess they only ceased operations in 2022, but it says it was a regional airline in Georgia. Okay, and so anyway, you got a bunch of these things. JetBlue Los is a thing. They are so their code whatever this code is, B6. Okay, and so they show up. Right here as B6 and so on and so forth. So in our table, we have the carrier by this kind of two-letter code. And, but unless you're working in the airport, you probably don't know what a lot of these things are, okay? And so, so what if we wanted to kind of join that information, right? There's, okay, we also, as far as destination, there are also a bunch of airport codes, okay? And so the airport codes, there are 1,458 airports in our table, and the FAA airport code is something like LAX, okay, or JFK, or I think LaGuardia is LGA, and Newark, I don't know what Newark's airport code is, and so on and so forth. And, flights originating from New York can end up going to, any of these other kind of different places. And so, so this is what we have, right? A lot of these are like municipal airports or, little like airfields, okay? But they still have an FAA code. All right, so how do we kind of match this up, right? Well, we can do, I want to take the flights table. I want to left join it with the airlines table. Again, the airlines table is just 16 rows and 2 columns where we just have the different airlines represented, okay? And we're going to say, okay, carrier equals carrier. So we're looking at the carrier column, which has these 2-letter codes, and we're looking at the carrier column, which is the same 2-letter codes in the airlines table, and we say, hey, we want to join it here, okay? And after you join them, okay, select, some of these columns from month to, say, arrival time, and then make sure you select the carrier column, make sure to select the name column, okay? And so we could say, oh yeah, there was a flight, departure at 5:17, scheduled to depart at 5:15, 2-minute delay, it arrived at 8:30, and that was run by United Airlines, and we can kind of see, okay, there's JetBlue, Delta Airlines, ExpressJet, and so on and so forth. Okay, so we can start to kind of add this thing up together. Now that we have this, we can also do summary operations, and we can say, all right, which airlines kind of have the most flights in coming out of New York, right? So what can we do? So we can do flights. We'll group by carrier, okay? So if I group by carrier, it's just using the two-letter code, and all we're going to do is we're going to say summarize, just count how many rows there were, right? And I think there was like 330-something thousand rows, 300-something thousand rows. And we're going to say, okay, group by how many flights there are, arrange them in descending order by count. So we can put the most frequent airlines there. And then just so we understand what these things are, we will join to the carrier table, okay? I'm sorry, the airlines table, and include kind of the name here. So we can see, okay, United Airlines had the most flights with 58,666 flights in 2013. JetBlue had 54,635 flights. ExpressJet had 54,173. So I don't know what happened to ExpressJet, but they had a lot of flights, and I don't know where all of those flights are now. If they've ceased operations, right? Did it say? ExpressJet in September 20, the company originally operated as a code share, including its brand AHA, filled for bankruptcy and ceased all operations. Okay, well, we don't even know. Corporate independent. Okay, oh gosh, there's a lot of information about some airline that I never really cared about, I guess. All right. And then, so we have all of these things, and, and you have like Hawaiian Airlines, 342 flights. So probably, Hawaiian Airlines, I don't know. I'm guessing they have like one flight a day that goes to Hawaii, or maybe 2 flights a day, I don't know, right? Type of thing. So, okay. So here, I did group by carrier, summarize, counts, arrange, left join after, right? So notice the left join comes after the summarize and the arrange, okay? What happens if I do the left join first and then I do the summarize, okay? So I said group by carrier, and then we left join, and we would expect the names, but then I summarize afterwards, what happened? That name column is gone, right? Because I grouped by carrier. So when you do a summarize, the only things that appear after you do summarize are basically any columns that you specify in the summarize. So here I only specified one column, which is counts. Okay, I could have also done, I don't know, mean or max or something, some other kind of operation. And then, so the only thing that shows up in the resulting table is the columns I specified in counts and the columns that we use to create the groups. So here I am only using carrier to create groups, right? So I didn't say group by the name. Okay, so here what results is I still only have the carrier information here. So you kind of want to think about, do I join the data after I've summarized, or do I summarize after I've joined the data? And the answer is going to be, it depends, right? If you need this information as part of your summary operations, you got to do it before. If you want this kind of to display afterwards, you got to do it afterwards. Okay, so things to keep in mind. Let me give you your last view quiz answer. Last view quiz answer today is A. A as in apple, or airlines. A. Okay. Okay. The last couple slides here is you can do multiple joins for multiple tables. So again, if you have like 3 tables and you want to join them, you can join table A to table B, and then after you do that, you join table C, right? So joining operations only do 2 tables at a time, but basically after you do a join, that's 1 table, right? And then now that you have that table, you can join it with another table, okay? So here I'm doing flights. I'm going to join it to the airlines table. And then that resulting table, which doesn't exactly have a name, okay, we're going to join it to the airports table. Okay. And you'll notice we have a name X and a name Y. So what's going on here is this table, the airlines table, has carrier and name. Okay. The airports table also has a column called name, FAA code, and name of the airport, right? So now dplyr says, oh, you know what? You've got the column name, and they're like different values, right? So this is, we joined the flights table with the airlines table. So originally it's going to have the flight information and the name of the carrier, because we've joined it with the airlines thing, okay? And then after we did that, we joined it with the airports code. So this name corresponds to the airport name, and dplyr goes, oh, wait a second, that's something else. So how do we differentiate these? It just kind of tacks on a name.x to say like this was your first one, and then you get name.y to say you got the second one there, okay? And if we were to join another one, we would get like name.x.x and name.y.x and name.x.y, and it just gets real messy real fast there. So how do you handle something like that? You can add a suffix, okay? So rather than using the default of .x and .y, you can add a suffix, and you can say, okay, you know what, I know ahead of time, I know there's a column called name, I know there's another column called name and the other thing. This one is coming from the kind of the carrier or the airlines table, so we're going to add the suffix name underscore carrier, and over here we're going to add the suffix name underscore destination because we're matching it with the FAA destination. All right. This is kind of a lot of stuff, and the best way to learn is by trying it out. So you've got a little bit of practice in Data Camp, and Data Camp will just give you a tiny little taste. And really, I think a lot of it's going to happen when you actually have to go out and you want to actually try to join tables and stuff like that. If that's part of what you're going to be doing, then you'll get some practice there. Okay, sorry for going a little bit over time, but we'll go ahead and end here for today, and we will see you on Friday. Please come to class on Friday. I will give you extra credit if you form your groups on Friday. Okay, see you later.